Hello, my name is Afonso Mota. I am here today to present my pitch for the thesis planning and scheduling. I am currently studying my PhD in electrical and computer engineering. My first supervisor is Professor Dr. António Valente from Mota. The second is André Almeida from Docotoral Technologies. My thesis will be entitled Indoor Air Quality Monitoring and Preditive Mechanism to Optimize an Automated Natural Ventilation System with automated windows and its smart home compatibility. Since my master's degree, I have been collaborating with a smart home research and development company called Docotoral Technologies, where the purpose was to develop new smart devices to the smart home market. Along these years, my passion for embedded systems, sensors, and wireless technologies has been evolving, and therefore I started my PhD program along with this company, the Otima, which has been providing substantially the means for my research. However, the company's paradigm has changed quite a bit in the last year. Now the focus has become indoor air quality control with automated natural ventilation, and then we apply this to the smart home market. The main purpose is to provide comfort to building occupants while maintaining the air quality and reducing the energy consumption, for instance. Basically, this project aims to monitor air quality, which means several gases, temperature, humidity, and pressure. Then, with this information, create large data sets to feed to machine learning algorithms, which will be in charge of predicting air quality, scheduling the opening and closing of automated windows, therefore improving the natural ventilation process and its efficiency. The global objective is researching and measuring the main pollutants in indoor environments with wireless sensor networks. We want to obtain accurate air quality models of each building and then predict the best time to naturally ventilate the building, recurring to machine learning algorithms. So, firstly, we want to research air quality measurement techniques, followed by the development of an embedded system that will be capable of sensing different types of gases and transfer data with its wireless capabilities and an internet connection. Secondly, we want to design a machine learning model capable of predicting the concentrations of the pollutants, and so we can best schedule the ventilation process. Third, we want to generate responses to actuators, such as motorized windows, and measure the impact of the natural ventilation without predictions and with predictions, therefore implementing a comparative study between these technologies. Fourth, we want to compatibilize the described architecture with the most known smart building infrastructures to allow end users to deploy these devices into their own existing systems, such as smart offices and smart homes. In fifth, we want to do a performance evaluation of the methodology, namely its health benefits to humans and the socio-economic impacts of the end-to-end system. This is my timeline. It's divided in four, and the first one is air quality monitoring system, where I will develop an hardware and firmware, so I have an embedded system capable of measuring these pollutants. Secondly, I want to develop a model, train, test, and deploy it to improve the natural ventilation process. Thirdly, I want to compatibilize the system, the developed system with the most known smart building infrastructures. And finally, in the fourth, I want to test my end-to-end system and write my PhD thesis. This is the Gantt chart that shows visually what I just explained. It's made for 2 years, and it's developed. It's divided into the four main topics I just described. This is my curricular plan. I have communication networks and technologies, where I will focus on smart homes, networks, architectures, and topologies. Then I have microsensors and microactuators, where I will focus more on the Trombo-All IoT automation system. This is my graphical abstract, which that explains visually what I just showed you now. Firstly, I will measure data from different buildings, gather this data to send to the cloud, where I will treat it and feed it to machine learning algorithms, which will generate predictions of indoor air quality, extrapolate routines, and schedule optimal natural ventilation inside the building, where actions will be taken, and therefore will be improved occupants' comfort, and energy consumption will be reduced. Below, there is a more technical way of seeing the things. I will sense with different kinds of sensors, some optics, some metal oxide, and other types. Then I will communicate with MQTT via with SSL, so communications can be done securely. Then I will probably use a random forest algorithm to learn and predict the best time to actuate on motorized windows. I am Afonso Mota. I hope you liked this presentation. If you have any further questions, please do not hesitate. Thanks.